Here's the next video for section 1.3. It's about square roots. So before, when we were talking about squares, we were saying, let's see if I can draw this nice and large here. If I had a 4 by 4 square, I'm going to make this in inches, but it doesn't matter if it was centimeters or meters. So there's a 4-inch by 4-inch square. And we remembered that when we broke that up, or we figured out, when we figured out the area, we found that we would get 4 times 4 squares resulting. So a square with side length 4 inches will give us 16 1 by 1 inch squares. We have 16 because area equals 4 times 4. So we have 16 squares here. And that's the same as saying 4 squared equals 16. That's the meaning of 4 squared. It means we have the 4 is one side length of a square. And if we know one side length of a square, we know all 4 sides because squares have only one side length. Then what is a square root? Well, a square root is the opposite. We start actually, notice when we do a square, we start with a side length. We square 4. Or if it was 10, it would be 10 squared. When we do root, we start with the number of squares here. So in this case, we have 16 squares. So we say, what is the root of a square that has 16 identical squares in it? Doesn't matter if they're 1 by 1 inch squares, whatever. As long as these 16 squares are identical, and together they form a square, what would the side length be that would have created that square? Again, so if we have 16 squares that make up a bigger square, what side length did they come from? So we write it like this, root 16, and we know, because we just did that root 16 is 4, because it would be a side length of 4 that we would square that would produce these 16 squares. So the root of 16 is 4. Well, what if we had a square with 25 squares? What it's really asking is, what two numbers that are the same that we multiply together will give us 25? And that is 5, because 5 times 5 equals 25, so the root of 25 is 5. That's the root. Again, if we had a square that had 25 squares in it, so I'm just going to draw this roughly, not to scale. So 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. Here we have 25 squares. We're pretending that they're all the same size. So the question is, when we do root of 25, we're saying we have 25 squares in this square. What's the side length going to be? Well, the side length is 5, because we know that if we do 5 times 5 for area, we'll get 25 squares. That's another way to understand what square root means. So let's look at our table now. And I like to use this table because it shows you a lot of squares at the same time. So if we had, or rather square roots. So if we had 1 and we did the square root, we put that symbol in, that means square root. What's our answer going to be? Well, the work, again, I like to think of what number times itself will give us this number inside the root box. Well, we know that's going to be 1 times 1. So square root of 1 equals 1. Square root of 2, a little bit trickier. So again, what number times what number will give us 2? Well, we kind of have to get a calculator for that. And actually, most calculators, like this one, will allow you to go 2, and then there's a little root sign up there. And that tells me it's 1.41. So I know that 1.41 times 1.41 will give me approximately 2. So the root of 2 is 1.41. It's a decimal that keeps going, but that's good enough for now. Root of 3. Well, what number times itself will give us 3? Well, because it's not what we would call a perfect square, I'm going to go to my calculator and type in 3 root, and I get 1.73, approximately. I'm going to put approximately here because it's not exact. So approximately 1.73 times 1.73 would give us root 3. Now, what about root 4? Well, that's a little bit easier because root 4, we know what number times itself will give us 4. Well, that's 2. So root 4 is 2. So there's a whole bunch of numbers that are easy, like root 1, root 4. What's the next easy number? Well, root 5 is not going to be easy, because what number times itself will give us 5? That's not a whole number, so I'll use my calculator again. That's going to be 2.23 times 2.23. So approximately 2.23 is the root of 5. Let's skip all the way down to 9. Root 9. What number times itself will give you 9? Well, that's going to be 3 times 3, so the root of 9 is 3. So you'll notice here that there are certain roots, like root 4, root 1, root 9, that will give us whole numbers as answers. These are called our perfect squares. And those are the perfect squares that if you look back at our squares, they're related. 1 squared gives us 1, 2 squared equals 4, 3 squared equals 9. These are the perfect squares, 1, 4, 9, 16, because when we take the root of these numbers, it brings us back to this number here, 1, 2, 3, 4. Okay, so back again here, the root of a number. When you have a root of a number like root 1, you want to find out what number times itself will give you the number inside here, and that becomes the answer. Some people think that root 1 equals 1 squared. That is not correct. For example, root 4 is not 2 squared. 2 squared is equal to 4. Root 4 is simply equal to 2, not 2 squared.